Have you ever stopped to think about how software, keeps things neat and tidy behind the scenes? Like imagine you're building something where you absolutely cannot have duplicates.
Yeah, that's a super common problem.
Right. Maybe unique user IDs or product codes or even just making sure an email address isn't on your list twice. How do they do that efficiently?
Well, that's where some core tools come in handy.
Exactly. And today we're doing a deep dive into one of those fundamental tools in Java programming designed for exactly that, Java sets. So our mission here is to really get under the hood of sets in Java. We're not just talking basics. We've looked at why they're so important for, well, building solid, efficient systems. We'll
hmm
cover what they are, of course, but also why they matter, how they actually work, and what you can, do with them. It's about understanding a key pattern you see everywhere.
And what's really fascinating, I think, is just how universal this idea of a unique collection is. It pops up everywhere.
Oh, definitely.
Managing a guest list for a party, right? Or think about data integrity in some complex financial system.
Yeah.
You need to prevent duplicates. And Java sets offer this, well, elegant and pretty optimized way to handle it.
Okay, so let's unpack that. What is a set in Java, fundamentally?
Right.
At its heart, it's basically a special container, part of Java's collections framework, which is like this big toolbox for handling groups of data.
A very powerful toolbox, yeah.
And its main job, its superpower, you could say, is storing only unique items. Try to add something that's already in there.
Nope, it just ignores it, keeps things clean.
Exactly. It maintains that uniqueness.
And this isn't just a surface level check. When you add something, Java looks at its hash code and its equals method. It uses those to figure out efficiently if an identical item is already present.
Ah, okay, so it's a proper check.
Yeah, it's about true uniqueness
Yeah.
defined by how those methods work for that object. If it sees the duplicate based on that check, the new one just doesn't get added. And crucially, while the most common type, hash set, doesn't really care about order.
Right, that's a common gotcha. Things aren't necessarily in the order you added them.
Exactly. But other types, like linked hash set, do keep the insertion order. And tree set actually sorts the items. So, that difference in ordering is often really key when you're picking which set to use.
That's a great point. The fact that set is an interface, like a contract, and you have these different ways to fulfill it. Hash set, linked hash set, tree set, offering different trade-offs.
Precisely. Performance, ordering. You choose what fits the need.
Maybe another way to think about it, like a digital music library. You want only one copy of each song, right? Even if you accidentally try to add it again.
Perfect analogy. A set would handle that automatically.
Yeah.
Deduplicates it for you. Keeps the library manageable.
All right, so we know what it is, how it keeps things unique, but why choose a set over, say, just a regular list? This is where it gets quite interesting, I think.
Yeah, definitely. It's not just about convenience, so that's part of it. It's often about building more robust and scalable systems.
Yes.
Well, first off, data integrity. Preventing duplicates is absolutely vital for things like unique user IDs, product codes, you name it, critical stuff.
Can't have two users with the same ID, yeah.
Exactly.
Yeah?
And then there's speed. Checking if something is already in a set, super fast, even with like millions of items. That speed boost really matters in real applications.
Okay.
Plus, it simplifies things. The set handles the duplicate checks automatically, so you don't have to write complex, error-prone code yourself. Fewer bugs, cleaner data.
Right.
And importantly, they're built for those mathematical set operations, combining sets, finding overlaps, finding differences. Lots of algorithms rely on those.
The cost of not using a set can actually be pretty high if you think about it. Imagine writing code to manually check a huge list for duplicates every time you add something.
A performance nightmare.
Yeah.
Or worse, maybe security issues if duplicate accounts somehow sneak in.
Yeah.
Just handle that. Let's developers focus elsewhere. Like that email marketing example, use a set for subscriber emails.
Duplicates get rejected instantly from signups or imports. Keeps the list clean, makes campaigns run better, and crucially, doesn't annoy people with the same email twice.
Spot on. It avoids so many potential headaches down the line.
So we've got the what and the why. Let's maybe peek behind the curtain now. How do they actually work this magic? How does it know if something's unique?
Right. It loops back to those hash code and equals methods we mentioned earlier.
Okay.
When you try to add an item, the set first calculates its hash code. Think of this like a quick address or a bucket number. It tells the set roughly where to look.
Gotcha. Narrows it down.
Exactly. Then, within that bucket, it uses the equals method to see if an item that is truly equal is already there. If the hash codes match and equals
Yeah.
says they're the same, then bam, it's a duplicate. Ignore it.
Ah, so it's the two-step check.
Yes. And if either the hash code is different or the equals check fails, then it's considered unique and gets added. This whole process is why adding and checking are usually very fast, especially in hash set.
And tree set is different.
Yeah, tree set relies on its sorted structure. It uses either the object's natural order, defined by comparator, or a separate comparator you provide to keep things sorted and, as a result, unique. So, different mechanism, same outcome, no duplicates. The main thing is they're really optimized for this.
So the speed isn't accidental, it's baked into the design.
Absolutely.
Okay, another quick example maybe. A university course enrollment. Each student ID should only be in the course list once.
Perfect. Use a set for the student IDs in that course. If someone tries to enroll twice, maybe they hit the button again or something.
Yeah, it happens all the time.
The set just ignores the second attempt, keeps the roster accurate, saves a lot of admin trouble later.
Makes sense.
Right.
Okay, so we know what they are, why they're great, how they work roughly. But what can you actually do with them in code? Let's get practical.
Yeah, this is where they really shine. You got the basics, obviously. Adding items, duplicates handled, removing items, checking if an item exists, that fast lookup we talked about.
The membership check, right.
Exactly. And counting how many unique items you have. But the really powerful stuff is the set algebra. You can combine two sets, that's called a union, get all the unique items from both.
Okay.
Or you can find only the items that are in both sets, that's the intersection.
Ah, like finding common elements.
Precisely. Or you could find the difference items in one set but not the other. These are super useful for filtering data, comparing lists, reconciling different data sets, all sorts of things.
Connecting that back. These operations sound like they'd simplify algorithms a lot. Like an online store wanting to find customers who bought product A and product B.
Exactly. Doing that with plain lists, you'd be writing loops, inside loops, checking conditions.
Yeah.
Messy.
Yeah, I can picture that.
With sets, finding the intersection is often just one clean, optimized operation. So much simpler and usually faster. Or that ticketing system example again.
Right.
A set holds unique ticket IDs. You add when sold, remove it's refunded, check validity at the door, count attendees, maybe combine attendee sets from Section A and Section B to get one unique list of everyone inside. It just makes that kind of logic way easier.
So for anyone learning Java, getting a handle on sets seems like a really key step for managing data effectively. They look simple, but they pack a punch.
Oh, absolutely. And to really get good with them, I'd say first, make sure you truly understand hash code and equals. Seriously, they're fundamental.
I get those right first.
Yeah. Second, don't just use hash set. Play with linked hash set, see how it keeps order. Play with tree set, see how sorting works. Maybe use a custom comparator.
Explore the different flavors.
Definitely. Third, try coding real things. Small projects like track unique website visitors or find common words in two articles. Get your hands dirty.
Practical experience.
And fourth, think about performance. When is hash set faster? When might tree set be better, even if it's sometimes slower for ads? Understanding those trade-offs is important. Which, kind of leads to the question, where do you go next?
Yeah, what's the next step?
Well, look beyond the basics. Check out open source Java projects. See how sets are used in graph algorithms or database indexing, maybe even in compilers. See them in the wild.
See how the pros use them.
Exactly.
And maybe a couple of things to watch out for. Common mistakes.
Good point. Number one is expecting order when you're using something like hash set. Don't assume it unless you chose an implementation that guarantees it.
Right, that ordering thing.
Yeah. And number two is maybe forgetting about the automatic uniqueness. Sometimes beginners get confused why their ad call didn't seem to do anything. It's because the item was already there. Just trust the set.
Will it do its job?
Pretty much. And finally, maybe dig into the data structures behind them. Learn a bit about hash tables, which power hash set, and balanced trees like red-black trees, which often power tree set.
Ah, understanding the why behind the speed.
Exactly. It really deepens your appreciation. Oracle's Java docs, good data structures, books, they're your friends there.
So we've taken quite the deep dive into Java sets today. We've seen how they're really this essential tool for locking down uniqueness, making data management cleaner, and enabling some pretty powerful, efficient operations from guest lists, like you said, to ticket sales, customer lists, algorithm optimization. This idea of a unique collection is just fundamental.
It really is. And maybe a final thought.
Hmm.
Next time you're using an app, signing up for something, seeing trending topics, whatever, just take a second to think about sets potentially working behind the scenes.
Yeah.
How much more complicated, how much messier, how much slower might those everyday digital experiences be if we didn't have tools precisely engineered to handle uniqueness so well?
Yeah.
What kind of errors or annoyances might creep in?
That's a great point. Makes you appreciate the hidden complexity. So maybe think about other places in your own work or life where keeping things unique is absolutely critical. Inventory, asset tracking, that perfect no repeats playlist. How could this concept of a set apply there? It's fascinating how these core programming ideas show up everywhere.